Okay, so in this video, we are going to have a quick look at our solar system. Essentially, we will cover 3 points. When was the solar system formed? What it is composed of? And how was the moon formed? Now, the solar system was formed obviously from a nebula, which is supposed to have started its collapse and the core formation about 5 to 5.7 billion years ago, which was then followed by the planets forming all at the same time about 4.6 billion years ago. In terms of the composition of the solar system, we have one sun and there are 9 planets, or 8 if we don't count Pluto, as many people don't consider these days as Pluto is a planet. There are 63 moons, and there are millions of smaller bodies like the asteroids and the comets, as well as a huge quantity of dust grains and gases. Now, in terms of the planets, we group them into 2 categories. The inner planets, known as Mercury, Venus, Earth, and Mars, they are known as inner planets because they lie between the sun and the belt of the asteroids. The other 5 or 4 planets are called the outer planets. Now, alternatively, the first 4 planets are also called terrestrial planets because they are Earth-like. They are made up of rock and metals and they have high densities. On the other hand, the outer planets, also known as Jovian or gas giant planets. Jovian simply means Jupiter-like. And these planets include Jupiter, Saturn, Uranus, Neptune, and Pluto. It's now not considered a planet, but I've just included it here for the sake of continuity. These planets are much larger than the terrestrial planets and have a very thick atmosphere. They are also made up of helium and hydrogen, and all these planets were formed in the same period about 4.6 billion years ago. Now, one question you might have is, why are the inner planets rocky while the others are mostly gaseous form? And the difference between the terrestrial and Jovian planets can be attributed to 3 conditions. The first one is that the terrestrial planets were formed in the very close vicinity of the parent star, that is the sun, where it is too warm for the gases to condense to solid particles. The Jovian planets were formed at quite a distant location. The second point is that the solar wind was very intense nearer to the sun, and what it did is it blew off lots of gas and dust from the terrestrial planets. Now, because the solar winds are not at all intense to cause the similar removal of gases from the Jovian planets, they are still mostly gaseous. And if we look at the terrestrial planets, they are very small, and therefore their lower gravity could not hold the escaping gases. But that is not the case for the Jovian planets, which obviously are farther away from the sun. Now, having looked at it, let's quickly understand what the moon is. The moon is the only natural satellite of the Earth, and like the origin of the Earth, there have been various attempts to explain how the moon was formed. So, for example, in 1838, Sir George Darwin, he suggested that initially the Earth and moon formed a single rapidly rotating body, and the whole mass became a dumbbell-shaped body, and then eventually it broke. It was also suggested that the material forming the moon was separated from what we have at present, the depression occupied by the Pacific Ocean. So that was the first kind of theory, that both Earth and moon formed on a single rotating body. However, at present, the scientists do not explain either of these explanations, and it is now generally believed that the formation of the moon as a satellite of the Earth is an outcome of a giant impact, or what is described as the Big Splat. A body of the size of about 1 to 3 times that of the Mars, so huge body, collided into Earth sometime shortly after the Earth was formed, and it blasted a large part of Earth into space. And the portion of this blasted material then continued to orbit the Earth and eventually formed into the moon about 4.44 billion years ago.